Imagine this, an asteroid hurtling towards Earth aimed right at your city. What would happen? We've all seen the Hollywood movies, but let's delve into the science. The potential impact of an asteroid hitting a city is colossal, and we have real-life examples to illustrate this. Take the Chelyabinsk meteor event in Russia in 2013. An asteroid approximately 66 feet in diameter exploded over the city, releasing energy equivalent to about 500 kilotons of TNT. The shockwave alone damaged thousands of buildings and injured over 1,500 people. But it's not just the size of the asteroid that matters. The speed, composition, and angle of impact can all influence the level of destruction. An iron asteroid, for instance, would cause more damage than a stony one, and a direct hit would be more catastrophic than a glancing blow. An asteroid between 30 to 50 meters could potentially flatten a city, but the actual impact depends on many factors. But what exactly are these factors, and how do they influence the level of destruction? Let's delve into this. First, we have the asteroid's composition. Asteroids can be primarily composed of either iron or stone. Iron asteroids, despite being less common, pack a heavier punch. They're denser, harder, and more likely to survive the fiery descent through Earth's atmosphere without breaking up. This means that an iron asteroid can hit the ground with a greater force than a stony one of the same size, causing more damage. Next, there's the speed of the asteroid. The faster an asteroid is moving, the more kinetic energy it has. And kinetic energy, my friends, is what gets converted into the explosion when an asteroid impacts. So, a faster asteroid means a bigger bang. Then we come to the angle of impact. A direct, head-on collision would have devastating effects, as it would dump all its energy into one spot. But a glancing blow, where the asteroid strikes at a shallow angle, could still be disastrous. It would spread the energy over a larger area, potentially causing widespread damage. But it's not all about the asteroid. The city itself plays a role too. The size of the city is an obvious factor. The larger the city, the more area there is to be damaged. But the layout of the city also matters. A densely packed city could suffer more damage than a sprawling one with lots of open spaces. And let's not forget about the construction materials. Buildings made of wood or other light materials could be more easily flattened than those made of concrete or steel. But even sturdy structures can be damaged by the shockwave from an asteroid impact. In essence, the devastation an asteroid can cause isn't just about its size. It's a complex interplay of several factors. So, while we can make general estimates, the specific circumstances of any given impact would significantly influence the extent of the damage. The devastation an asteroid can cause isn't just about its size. It's a complex interplay of several factors. Let's go back to the Chelyabinsk event in 2013 for a moment. On February 15th of that year, an asteroid, estimated to be about 20 meters or roughly 66 feet in diameter, exploded in the skies above Chelyabinsk, Russia. Now, 20 meters might not seem like much, but when we're talking about an asteroid, it's not just about size. The kinetic energy of the asteroid as it hurtles through space, the angle at which it meets the Earth's surface, its composition, all of these factors come into play. In the case of Chelyabinsk, the asteroid was traveling at a speed of around 40,000 miles per hour. Combine that with its size, and you get an explosion equivalent to about 500 kilotons of TNT. That's over 30 times the energy released by the atomic bomb dropped on Hiroshima. The asteroid didn't hit the city directly. Instead, it exploded in the atmosphere some 18 miles above the ground, creating a shockwave that spread across the region. The force of this shockwave was so powerful that it damaged thousands of buildings and injured over 1,500 people, mostly due to shattered glass from the shockwave. The Chelyabinsk event is unique not just because of the damage it caused, but also because it's the most significant asteroid event in modern times that we have detailed records of. It's given scientists valuable insights into the potential impacts of similar events in the future. The Chelyabinsk asteroid was made of a common type of rock found in space, called ordinary chondrite. If it had been made of a denser material, like iron, the damage could have been even more severe. It's also worth noting that the asteroid came from the direction of the sun, which made it difficult to detect. This highlights the challenges we face in identifying and tracking potentially dangerous asteroids. The Chelyabinsk event is a stark reminder of the potential devastation an asteroid can cause, even if it's relatively small. So, how big does an asteroid need to be to destroy a city? Let's delve into that. Imagine an asteroid, not much bigger than a 5-story building, hurtling through the vast expanse of space. This space rock, measuring between 30 to 50 meters in diameter, might seem insignificant compared to the infinite cosmos, but it holds the potential to wreak havoc on our urban landscapes. When such an asteroid strikes the Earth, it's not the size alone that matters. The impact releases an enormous amount of energy, equivalent to several megatons of TNT. This is no small firecracker. We're talking about a force capable of flattening buildings, rupturing gas lines, and obliterating infrastructure over a broad area. It could potentially devastate a small to medium-sized city. But let's not forget the Chelyabinsk event in 2013. The asteroid that exploded over Russia was just 20 meters in diameter, yet it released energy equivalent to about 500 kilotons of TNT. Even though it didn't hit the city directly, the shockwave damaged thousands of buildings and injured over 1,500 people. However, it's crucial to understand that the actual impact effects would vary. The speed at which the asteroid strikes, its composition, and the angle of impact play significant roles. For instance, an iron asteroid would cause more damage than a stony one, given its greater density. Similarly, a direct hit would be far more catastrophic than a glancing blow. In essence, an asteroid doesn't need to be the size of a mountain to destroy a city. A rock as small as 30 to 50 meters could do the job, given the right circumstances. But remember, the specific conditions of the impact, the speed, the angle, the composition of the asteroid, would significantly influence the extent of the damage. While a small asteroid could potentially destroy a city, the specific circumstances of the impact would significantly determine the scale of the devastation.